Hello everyone. In my last video we had seen the method of substitution. In this video we are going to study the method of integration by parts. We use this method if the integrand is a product of two functions, one of which is the derivative of some other function. Say you have two functions u and v. If u and v are functions of variable x, then according to this method, integration of the product will be u is the first function in the product and v is the second function. So keep u as it is, integrate the second function, minus integration, differentiate the first function, integrate the second function, and then integrate this product. Here u is the first function and v is the second function. Now how do we decide which function should we choose as the first function and the second function? So the order in which two functions are to be taken as first function and second function is according to the serial order of the letter of the word liet. Here L stands for logarithm function, I stands for inverse trigonometric function, A stands for algebraic function, T stands for trigonometric function, and E stands for exponential function. Let us take an example to illustrate this. Suppose I have to integrate x into cos x dx. So notice here that I have two functions here, x and cos x. So which of these should I choose as u and which of these should I choose as v will depend upon what kind of these functions are. X is algebraic function and cos x is trigonometric function, and a comes before t in the word liet. So u will be x and v will be cos x. So if I keep this in my mind, my u is x and v is cos x. The formula tells me to keep the first function as it is, integrate the second function, minus differentiate the first function with respect to x, integrate the second function, and then integrate this product. Continuing further, integration of cos x is sin x, minus integration, derivative of x with respect to x is 1, into integration of cos x is again sin x dx. So this is x sin x minus integration of sin x, which is x sin x minus integration of sin x is minus cos x plus a constant. So its answer is x sin x plus cos x plus a constant c. Let us now take this example. This is a product of two functions. One is e raised to the power 3x and the other one is sin 4x. Remember the word liet. So this would tell me what will be u and what will be v. You have an exponential function and a trigonometric function. Trigonometric function comes before exponential function in this word. T comes before e. So trigonometric function will be the first function and exponential will be the second. So I can write this as sin 4x into e raised to power 3x dx. This is u and this is v. And follow the rule which says keep the first function as it is, integrate the second function, minus integration, differentiate the first function, integrate the second function, and then integrate its product. Continuing further, sin 4x, integration of e raised to the power 3x is e raised to power 3x upon 3, minus integration, derivative of sin 4x is cos 4x. 4 is multiplied here because it is differentiation into, again integration of e raised to power 3x is e raised to power 3x upon 3, this dx. I will rewrite this as 1 by 3 e raised to power 3x sine 4x minus 4 in the numerator, 3 in the denominator comes out as constants into integration cos 4x into e raised to power 3x dx. This has already been integrated. I still have integration sign here. I have the product of two functions. Again, I will use the product rule, the UV rule. That is integration by parts. This term is as it is, minus 4 by 3. I have a trigonometric function and an exponential function. Trigonometric t comes before e, so this is u and this is v. Again apply integration by parts on this section. So this would be, keep the first function as it is, integrate the second, minus, differentiate the first, integrate the second, and then integrate the product. So this will be 1 by 3 e raised to power 3x sine 4x minus 4 by 3 times cos 4x into integration of e raised to power 3x. Integration of e raised to power 3x is again e raised to power 3x upon 3 minus integral derivative of cos 4x. It is minus sine 4x, and then by chain rule differentiate 4x, it will be 4. Integration of e raised to power 3x is e raised to power 3x upon 3. So this is 1 by 3 e raised to power 3x sine 4x minus, if I multiply 4 by 3 inside, this will be 4 upon 9 e raised to power 3x cos 4x. Minus into minus becomes plus, and plus into minus becomes minus. 4 times 4 is 16 upon 3 times 3 is 9 e raised to power 3x sine 4x, of course with the integration sign dx. Now this integral and this integral is same, so I will keep on getting this integral, so I have to stop somewhere. So what I will do is I will name this integral as I. I will call this integral which I have to solve as I. So this is I is equal to 1 by 3 e raised to power 3x sine 4x minus 4 by 9 e raised to power 3x cos 4x minus 16 by 9 times I. So minus 16 by 9i comes to the LHS and becomes positive. So this is I plus 16 by 9i is equal to 1 by 3 e raised to power 3x sine 4x minus 4 by 9 e raised to power 3x cos 4x. I take LCM here. This is 9. 9 plus 16 is 25i is equal to 1 by 3 e raised to power 3x sine 4x minus 4 by 9 e raised to power 3x cos 4x. So integral this would be 9 goes up, 25 comes down. So 9 by 3 into 25 e raised to power 3x sine 4x minus 4 by 9. 9 goes up, 25 comes down, e raised to power 3x cos 4x. So your integral will be 3 by 25 e raised to power 3x sine 4x minus 4 by 25 e raised to power 3x cos 4x. We can try many problems using this method of integration by parts. One thing to observe is that all inverse trigonometric functions and logarithm functions can be integrated by using this formula, this method, by taking the other function b equal to 1. Let's see how. Let's try integrating log x dx. Now here only one function is in the integrand, but I can write this as integration of log x into 1 dx. Now consider the word liet. Logarithm function is given preference over algebraic function. So consider log x as u and 1 as v and continue. Log x, first function as it is, integrate the second function minus integration of derivative of the first function, integration of the second function, take their product and then integrate. So this is log x into integration of 1 is x minus integration derivative of log x is 1 by x. Again integration of 1 is x dx. X and x cancels off. This is x log x minus integration of 1 dx, which is x log x minus x plus c. So therefore integration of log x is this. Taking another example, suppose we have to integrate tan inverse x. Here again only one function, but I can write this as the product of two functions, which is tan inverse x into 1 dx. In the word liet, inverse trigonometric function is given preference over algebraic function. So consider this u and this v. Keep the first function as it is, integrate the second minus integration derivative of the first function into integration of the second function and their products integration. So this is tan inverse x into integration of 1 is x minus integration derivative of tan inverse x is 1 upon 1 plus x square into integration of 1 is x dx. So this is x tan inverse x minus integration x upon 1 plus x square dx. How do we solve this? By substitution method, which we have done in the previous video. Put the denominator as some variable t, differentiate both sides, you get 2x dx is equal to dt, but only x dx is in the numerator. So I will take 2 on the other side. X dx will be dt upon 2. So substituting it here, I will get the value of tan inverse x as integration of tan inverse x as x tan inverse x minus x dx is replaced by dt upon 2 upon 1 plus x square is replaced by t. So this is x tan inverse x minus 1 upon 2 outside dt upon t, which is x tan inverse x minus half of log t plus c. Replace t by 1 plus x square in your final answer, minus half log of 1 plus x square plus c. This is the answer for integration of tan inverse x. If you find this video useful, kindly hit the like and subscribe button, and do drop your comments in the comment section below. Thank you.